Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n square plus 8 times of log n equals to 0, and we will solve this problem for the values of n. So here we use the Lambert W function, and you know about this function. It will be stated as w of n times of e to the power of n. So the output of this function equals to n. So if I can write this Lambert W function in more particular form, then you have if you have 3 times of w of 3 times of e to the power of 3, so the output of this function equals to 3 only. So now we can solve this problem by using this nice Lambert W function. So that now first I can convert over this statement in this standard form of Lambert W function. In order to make this form, now first I can divide our given question on both of the sides by n squared. So when you divide both of the sides by n squared, then you will get here in this form n squared over n squared plus 8 times of ln of n whole over n square equals to 0 over n square. So now we divide first both of the sides by n square, and in the next step you will get here these n squared are cancelled by each other, and we obtain here 1 plus we move this n square on the upsides, and you write a times of ln n of n minus 2, and this whole equals to 0. So in the next step we will rewrite this expression as 8. We can write this 8 as 4 times of 2 times of, here you have ln of n, and we have this n to the power of minus 2, and this whole equals to 0. So in the next step we will take the log and the anti-log at the same time on n to the power of minus 2, and now we move this plus 1 on the right hand side, and you get 4 times of 2 into ln of 2, and we can take the log and anti-log on this term, and you get this is anti-log and this is log, because you know that when these are act on the same time, so these are cancelled by each other, and we write n to the power of minus 2, and this whole equals to, we move this one in the right hand side, and it is equals to minus 1. So in the next step you will see here we have e to the power of log of n to the power of minus 2, and when we use the property of logarithm, and we can move this minus 2 in the front of this log, and then we check that it will be looks like in this form. So 4 times of 2 into ln of 2, and e to the power of minus 2 times of ln of n, and you have, sorry, this is the ln of n, this is the value of n, and this whole equals to minus 1. So now in the next step we can first rewrite this expression because it is not cleared here. So 4 times of 2 into ln of n into e to the power of minus 2 of ln of n equals to minus 1. So now you see here we have, first I can check our standard form of Lambert W function. You know that the exponent of e is multiplied by here, and you see that the exponent of e is minus 2 times of ln of n. So when it is multiplied here, so we need only this negative sign. So now we can make, or we can multiply both of the sides by minus 1, and we move this 4 on the right hand side. So now first we move this 4 on the right hand side, and then you get 2 times of ln of n into e to the power of minus 2 times of ln of n equals to minus 1 over 4. Now we multiply both of the sides by minus 1. So when you multiply both of the sides by minus 1, then you will obtain here minus 2 times of ln of n into e to the power of minus 2 times of ln of n equals to this minus 1 over 4 will becomes plus 1 over 4 because we multiply both of the sides by minus 1. And now you see here we will make the exponent of e here. So now we're ready to apply the Lambert W function on both of the sides. So in the next step we will take this Lambert W function on both of the sides, and you get w of minus 2 times of ln of n into we have e to the power of minus 2 times of ln of n, and you have this Lambert W function, and this whole equals to w of 1 over 4. So in the next step we will make we will use the definition of Lambert W function, and you know that the output of this function equals to the exponent of e, which is n. So that here you have the exponent of e is minus 2 times of ln of n, so the output of this function equals to minus 2 times of ln of n, and this whole equals to w of 1 over 4. So in the next step we will make here little bit simplifications. Here we use the property of log, and we move this minus 2 in the up in the exponent of n. So you write ln of n to the power of minus 2 equals to w of 1 over 4. So in the next step we remove this log because we need to find the value of n. So in order to remove this ln, we can take the anti-log on both of the sides, and you get here e to the power of ln of n to the power of minus 2 equals to e to the power of w of 1 over 4. So now in the next step you will see here this e and ln are cancelled by each other, and we will get here n to the power of minus 2 equals to e to the power of w of 1 over 4. So here we move this n to the power of minus 2 in the downside, and you write it as 1 over n squared equals to e to the power of w of 1 over 4. So now first I can take the reciprocal on both of the sides, or we flip both of the sides, then you get here n squared equals to 1 over e to the power of w of 1 over 4. So now in order to find the value of n, we need to take the square root on both of the sides, then you will obtain its output in this form. So in the left hand side you see that these 2 and square root are gone, and we get here n equals to plus minus 1 over square root of e to the power of w of 1 over 4. So this is our final answer of this problem. So if you can see the exact solution of this of the right hand side, then you can use the Wolfram alpha to get the exact numbered solution. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.